We're now going to look at solving a new type of equation. And the type of equation we're going to look at is called a radical equation. That basically means that our equations are going to have square roots inside of them. One thing that we have to remember that's very important is that square rooting and squaring are pretty much the opposite of each other with the correct restrictions. In other words, if you have a square root inside of an equation, you can get rid of that square root by squaring. And the opposite is actually also true. If you have, under certain circumstances, if you have a square in an equation, square rooting can help you solve. So that's what we're going to look at doing. Now there's several step process that we have to go through for these problems. First thing we always have to do is isolate the square root. In other words, you want the square root portion of the equation on one side of the equation by itself. Anywhere where you can combine like terms, you're going to want to do that next. That's going to make it possible for you to square fewer terms. Then it'll finally be time, step 3, to square both sides of the equation. This is where we're going to have to use the most caution to make sure we square properly. You then will solve for the variable. Depending upon what type of equation results from squaring, there could be more than one way to solve. For example, if we end up with a linear equation, we can just solve for the variable outright. If we end up with a quadratic, we'll have to set the equation equal to 0 and possibly factor. The last thing, and this is very important with this type of equation, is to check your answer. With this type of problem, you can get extraneous results. That means answers that you got using the correct process, but that just don't work in the equation itself. So let's start working some of these, and let's start off with some very simple and straightforward type examples. Let's look at square root of x equaling 7. Step number 1, isolate the square root. We see square root of x is already on the left side by itself. Step number 2, combine like terms. Well, there aren't any. There's only one term per side. So, step number 3, square both sides. Square root of x squared. What happens here is the square root is canceled out with the square, so nothing but an x comes down. There's no x squared or anything like that coming down. 7 squared is 49. So this problem was solved in a single step. But we still need to remember, always check the answer. So, I'll go back to the original problem, which was square root of x equals 7. Put in the 49, and that answer checks out just fine. Now, to illustrate why it's necessary to do this, let's look at square root of 3y minus 1 equaling negative 6. We will isolate the square root, and that's done. Combine like terms, there aren't any. So now we square both sides. The square root and the square cancel, so the 3y minus 1 is all that comes out of here. Negative 6 squared is a positive 36. I'm going to add 1 to both sides. Get a 3y equaling a 37. And when you divide by 3, your answer is 37 thirds. Or you could write that as a mixed number. You could write that, you could go to decimal form, but it probably wouldn't turn out very nice. Like I said, we always have to check our answer. So let's take 37 thirds and put it in. We'll do second square root of 3 times 37 over 3, that's 37 thirds, minus 1, and close the parentheses and take the square root, and we get 6. Now if we go back to the original equation, though, it said negative 6. So that doesn't check out. And the main reason was because of this negative 6. And I assure you, though, it's not always going to be this obvious that the thing is going to have extraneous solutions. but this time it did. So we need to make the comment that this has no solution. But again, it's not always this obvious. You always have to do a little bit of checking. All right, let's look at another one. Let's go with 11 equaling 6 plus the square root of x. This one has a little bit more work involved. On this one, we do have to isolate the square root, so I'll subtract the 6 over. And I'm going to turn it around, make it square root of x equals 5. Squaring both sides. Square and square root cancel. X equal 25. Now let's check it. 11 equal 6 plus square root of 25. 11 equal 6 plus square root of 25 is 5. 11 equals 11. That checks. It's a perfectly acceptable answer. Alright, let's look at a few more examples. Now, sometimes when you're squaring the side without the radical is not as obviously easy as these have been. If I had the square root of 2x minus 5 equaling x minus 4, the square root is isolated. Like terms, there are none to combine. So I'm ready to square both sides. Now this one's different from the previous, and here's how. The previous ones had nothing but a constant on the side once it was time to square. This time I've got a binomial. And the only good way to square the binomial to prevent mistakes is to write it down twice. So in essence what I'm doing here is squaring the x minus 4, but I'm doing it by writing it out. Now on the left we have our cancellation. On the right I've got the FOIL. First times first is x squared. Outer product is minus 4x. Inner product is minus 4x. And minus times minus will be a plus 16 on the end. Combining like terms on this one, minus 4x and minus 4x become minus 8x. And I see that I've got a whole different type of equation. This is quadratic. So I can't just solve for x straight out. I have to set everything equal to 0. So I'll subtract off the 2x. And I'm going to trade sides here for convenience. X squared minus 10x plus 16 equal negative 5. Then I add 5. X squared minus 10x plus 21 equals 0. Now, factoring. This is why we were so persistent in our factoring previously. A minus 3 times a minus 7 gives you minus 21. Give you positive 21 and add to be negative 10. So I set each factor equals to 0. You should be getting proficient at this by now. Oops. This should have been a minus. 7 equals 0. You got an x equals 3 and an x equals 7. Now I've got two answers to check. Alright, we'll try them both. Square root of 2 times the 3 minus the 5 is the square root of 6 minus 5, which is the square root of 1, which is 1. On the other side, is that equal to a 3 minus 4, which is a negative 1? No, this answer just didn't work. 1 doesn't equal negative 1. And it wasn't obviously clear in the beginning that this was what was going to happen. So I have to check the other one. Square root of a 2 times a 7 minus a 5 is the square root of 14 minus 5, which is the square root of 9, which is 3. Trying the 7 on the other side, does that equal 7 minus 4? Plugging the 7 in up there, and that one worked. So it appeared to have two solutions for a moment, when in fact it didn't. And these can do that very easily, so we really have to watch out. So we need to look at least another example or two for this type of problem. Let's take a look at a square root of a 4x minus 5 set equal to the square root of an x plus 9. Now this one's a little bit different in that you have a square root on each side. In other words, more than one square root. And that's not going to be a problem. because they are both isolated. There are no like terms to combine, so I can go ahead and square. Square root and square cancel. 4x minus 5 comes out. Square root and square cancel. X plus 9 comes out. This is linear. There are no x squares, so I can subtract x over. And add 5. And I can divide by 3. And now I've got another answer to check. Let's see what we get when I plug it in. Alright, remember, it was 4x minus 5, square root of that, and we're plugging in a 14/3. So second square root of 4 times a 14/3. Okay, and the next part was the minus 5. And we close our parentheses when we hit enter, and there's our answer. And let's see if we can get a match. The other side was the square root of x plus 9. So a second and a square root of a 14/3 minus 9. And what happened? Okay, was that supposed to be a minus 9? Oh, my mistake, it's supposed to be a plus 9. We will go back. Nice thing about this calculator is you can go back and overwrite what you did. And you see we got the same answer we did before once I corrected the minus and made it a plus. So we have verified that that is a working answer, and you will sometimes get strange answers like that, so you just have to be prepared for that possibility. Let's work one more. Let's take the square root of 8 minus 7x and set it equal to an x minus 2. Again, there are no like terms to combine. The square root is isolated, so I will square both sides. Here's another binomial. That's one of those I have to write down twice. Square root cancels the square, and the 8 minus 7x comes out. Here, first times first is x squared. Your outer product is a minus 2x. Your inner product is a minus 2x. Last times last becomes a plus 4. Combine some like terms. Again, we have a quadratic. We have to set equal to 0. So I will add a 7x here. And I get 8 equaling x squared plus a 3x plus 4. 8 from both sides. Now I'm going to change sides here again. X squared plus a 3x minus 4 equals 0. So factoring. X squared is x and x. The 4 will be a plus 4 and a minus 1 for our factorization. It's going to give us x plus 4 equals 0 and x minus 1 equals 0. So we're left with an x equal negative 4 and an x equal 1, both which need to be checked. I'm going to plug it in right down here. We're going to take the square root of 8 minus 7 times a negative 4, which is the square root of 8 plus 28. And that's the square root of 36, which is a 6. Now trying the other side. A negative 4 minus 2 is a negative 6. Those are not equal, so that doesn't check. Next one, square root of 8 minus 7 times the 1 is the square root of 8 minus 7, which is the square root of 1, which is 1. And plugging in the 1, 1 minus 2 is negative 1, not equal. So in some cases you might have one solution. In some, you check, neither one works. So again, we have to say no solution. So those are the procedures for solving these equations. Isolate the square root, combine like terms, square both sides, solve for the variable, and check those answers.